Okay, so today I'm going to show you guys how to set up the open source tools at your home. What you did during the course was on the cloud, and that obviously was for only for 2 weeks. So this setup will actually make you look exactly the same, almost exactly the same like what we are doing in the lab in the during the course, summer course. So that way, you will not have any uh, extra learning to do. So what we had on the cloud was actually a Linux distribution called LXLE, and there are a lot of Linux distributions out there, but most of their bases are actually the kernels plus a few of the libraries and all that are based off a few of the popular ones. And Debian is like one of the popular ones, and Ubuntu is actually based on the Debian one. So this LXLE is actually a Ubuntu-based Linux distribution. So pretty much everything you can do on Ubuntu, you can do it here, unless there's something specific to the display manager which is not allowed here, then you won't be, obviously. But for this lab, you'll be fine. So today, what I'm going to show you is I'll not show the installation of VirtualBox, so that part is already installed because that's a long process. But if you go to this document here, that'll walk you through the steps how to install VirtualBox and install Linux on top of it. Okay, and just to kind of give you a quick overview what VirtualBox is, like it says it's a virtual box. Because you guys, this is the assumption that you guys actually have a Windows desktop or a laptop, and we are all the Linux, the tools are meant for Linux. So you're going to create a virtual machine. So it's like a machine inside a machine, and you're going to load Linux in that virtual machine. So it'll be completely isolated from your Windows. I mean, it'll have, you can share your files and all that, but it basically looks like a desktop by itself, but it is actually running in Windows. Okay. And then you load Linux on it, and now you can run all your Linux software on it. That's the whole idea. If you already have a Linux desktop like Ubuntu or Xubuntu or Lubuntu or Debian based or LXLE or something like a Debian plus LXDE, actually the one you were using in the lab actually was a Debian running a display manager called LXDE. So if you already have that, then this part you can skip, and you just go to the download tools part and download those tools and start working. Okay. So my assumption here is for people who don't have anything yet, they want to start fresh. So um, this document is shared obviously on this page here, this one here, that PDF document. Uh, these were snapshots when I was installing the VirtualBox. There might be small differences as you're going around, so you might have to figure that around, but it should pretty much work for all of you. Okay, so the first thing you want to do is install the application VirtualBox from this site, virtualbox.org. This was actually Oracle before, and so the VirtualBox is now open sourced. And install it with all the default settings. And this is a pretty straightforward, just like any Windows app. You install it and you'll be done with it. Okay. Now, once your machine is ready, you need to download the Linux distribution, and this is a big file. I forget how big the file is, but what I would suggest is there are two types of, let me see, I think we, so if you click the file, so this is your LXLE desktop file. So these are your download reviews. So this is 32-bit, 64-bit. Looks like they don't have an option for network. Maybe they do. I think sometimes they'll have ISO for network installation. So in that case, what will happen is you download a small ISO file, and while the installation is going on, it'll pull pretty much everything from the from the web. But looks like this, you just dig deep into it. You can go to this site. You can also go to a site called distrowatch.com or .org. I think that's where you find all the distributions of Linux there. So you can grab it from there. Maybe they have a network version over there. In any case, so once you have the ISO file, so once you download this, you're going to get a ISO file which will say something like this: LXLE blah blah dot ISO, and make sure you get a 64-bit one. And I kind of say that in the steps here, because all these tools here, they're actually compiled for 64-bit. So if you do a 32-bit, it will not work. So you need to download a 64-bit. And if you have a laptop, 32-bit laptop, then you have to compile all these for 32-bit. And I actually have instructions in all these GitHub pages. I have the instruction. So if you're adventurous enough, you can actually do that. I mean, it's actually pretty straightforward. I didn't have any specific like problems which took me a while to figure it out. So it should be okay. Um, okay. So you download the ISO file, and once you download it, you keep it in a place where you can access it from the VirtualBox. Now start the VirtualBox. So the installing Linux on VirtualBox is two-step process. First, you create a virtual machine, and then you install LXLE on it. So that's why in VirtualBox, you can have many machines. If you have the disk space, you can have one Ubuntu, you have one LXLE, so you can make many virtual machines, as many as you want, given the disk space you need if you have them. So this is the first space where you're going to create a virtual machine like it says here. And you give a name, anything which describes it. Like for example, here I made it LXLE LTS 1804. So I know it's a Ubuntu 18.04 and LXLE distribution. So name something which you can recognize it. If you're doing many distributions, if you're just doing one, it's fine. And the type is obviously Linux. And the version, you can see I chose Ubuntu because the virtual machine in VirtualBox really doesn't differentiate between the sub distros of Ubuntu and Debian and all that. It has some specific things. I don't know exactly what, but some specific things related to the thing. So here, if you select Ubuntu for LXLE, that should work fine, and you should not. So let's say you are downloading Debian, then Debian, there is a drop-down menu for Debian, so you can choose Debian here, and then there is SUSE and other ones too. Then it'll ask you to select the size of the RAM, and this is the RAM of the virtual machine. When you start the virtual machine, what is the RAM? Obviously, it has to be less than your desktop or laptop. You need a minimum 1 GB is what it will recommend you, but I would say at least have 2. If you have 8, put 4. But you can see, as you can see in this graph, your system is warning you that as soon as you get close to like 6, it'll say that now your Windows doesn't have enough memory because you're sharing this memory from, so I have 8 GB memory, for example, on this one. So I chose 2, but you can choose. So the circuits and all that you'll be running, 2 should be fine. You should not. But if you start compiling and downloading a big JIT repos and all that, you might have issues with 2 GB. In fact, I did, so I changed mine to this. But for this lab, 2 is much more than enough. You should be fine with 2. And if you just have 2 GB memory, try it 1. Most probably you should be fine. And the next one is creating a hard disk. Again, this is the hard disk for your virtual desktop. So obviously it has to be less than the hard disk of your laptop or your desktop, and typically, a lot lower, because you might already have a 1 TB or 2 TB or 500 GB, um, hard disk already. So here you can see the one I'm going to show you has 20 GB. Again, 20 GB is good enough for what you're doing. But again, if you're trying to compile or get this large PDKs and do compilation and all that, then you might run out of space. But for this, it should be fine. Hard disk file type, just choose VDI, I think, which is the normal default one. Storage on physical hard disk, choose dynamically allocated. So that way, if you have limited hard disk space, even though you have done 20 GB, but if you're not using more than, let's say, 5 GB, it will not allocate more than 5 GB or whatever, 10 GB. It has smart algorithms to figure that out. So I would suggest to choose the dynamically allocated one as well. So you choose the size here, give a name for the hard disk and all that, hit create, and that's it. And once you do that, this is your virtual machine right now. And you can see this is a snapshot of my machine. Here I've actually already downloaded Linux because I think I did it later. But you can see I have another virtual machine, which is a CentOS here. So I've loaded CentOS on this. So so let's say I'm doing something which requires CentOS, then I can click this, click start, and it'll start the virtual machine. So now you have a virtual machine. So now this is equivalent to like you getting a laptop, but you don't have a OS, or you getting a desktop and you don't have a OS. So you have to load the OS on this machine now. So you have a machine with 2 GB RAM, like here, 2 GB RAM, 20 GB hard disk, 16 MB video and all that. This is the virtual machine. Now we need to load the OS on it. And just like you load on your desktops or this thing, here also you have to boot and choose the image. Now here, you downloaded that ISO file, you remember, from that Linux site. So this is where you have to tell him where it is. Now, I exactly forget how I think I had optical drive. So I just chose the storage as optical drive. ISO image was there in the DVD. I chose it and I started booting. But I'm guessing most of you are just going to use a USB drive, which you should be able to do fine. So I think if you put it in your USB drive, just choose USB and choose your image from there. Okay, it'll be very self-explanatory. So if you're doing from USB, it's fine too. So or you put it in a hard disk and make it accessible from your hard disk. Just do a little bit of Google search, you'll be able to find it. So either ways you can do it, or if you want to do it the way I did it, where I actually burnt it onto a DVD, and I had a DVD, I have an external DVD ROM, so I just booted off the DVD ROM. So you do that. So you choose the image wherever the location is, optical drive, USB drive, or your hard disk, wherever it is, and then when you boot it, it's going to boot from that ISO drive, and you're going to see it just like you were installing a new operating system on a desktop or a laptop. Okay, so you'll come to this install blah blah live and all that. Obviously, choose install here, and then bunch of um, self-explanatory options you have to choose. Download updates while installing. I would uh, download updates while installing is okay. Actually, I chose this, but for people who have a slower connection or a little bit flaky connection, I would say switch this off. So that way what will happen is you finish all the installation and you do the update in the end, and I'll show you, how you do that. So I would say probably click this off, otherwise it'll be a slow installation. Okay, so installation type, erase this and install LXLE, because that 20 GB is assigned just for this. So just choose that one. And then you're going to get this saying that writing the changes. Then it'll ask you a bunch of other questions. Where are you? Time zone. And then it'll come to ask you the username password. Now, uh, in the new Linux distributions, root is almost not there, the root where you have to do administration. Instead, what they have, what's called Sudoers. So they are like root users, where you have to actually use the command sudo, sudo, before every command if you want to execute as a root. So, and that first one it's going to ask you is actually going to be a sudoer. I think, is there an option here? So it's your name. So you just give your name here, computer's name, whatever you want to give, username, and that's the username you're logging in. You remember when you're logging into your um, lab instances, you had a username. So it's that same username. Give a password and make sure you write down this password. That's what I've written in bold here, because if you lose this, there's no way to retrieve it. You basically have to start all over again. So make sure you write it down in a safe place, typically in your diary or something. Don't, put it on your phone or on your public place or something like that, obviously. And then you choose that, it'll go on doing the installation. And after it is complete, it'll reboot once. And then in this virtual machine, you're going to come to this login page like you do for any desktop or laptop. And here, obviously, the name comes in. You just give your password, which you gave, and you'll be able to log in. Okay. The terminal you were using in your lab was actually installed by Napti, which is not there here. You can install it here also. You can do a sudo apt install. I think it's called, I forget what that terminal was called. I think it was x11-terminal or something like that. But obviously, there is already a terminal here. In the LXLE, it's called Sakura. Or actually, before you do that, update your system. And in Ubuntu or Debian based system, they use a package manager called apt. That's the package manager. And this is what I meant for doing anything root, which you need to do for doing update. You type sudo first and then the command. So the command is really apt update, but because this command has to be done by root, then you actually prefix that command with sudo. So that's a root execute. So you first do update. So in Ubuntu, it's like a two-step process. You don't have to always do that, but highly recommend you always do that, because first step update, what it does, it updates all the package list from all the mirrors and the webs and all that, and keeps it. So that way, you know, all the up-to-date packages and all that informations are stored right now. So this is usually a fast one. Then you do sudo apt upgrade, because the ISO image you're going to download, it's going to be an older one. It is usually when they started the distribution 18.04 Linux one. But there's been tons of pretty much every day patches come out to fix something, right, in these distributions. So this upgrade is going to, first time when you do this, it's going to take a while, because there will be at least 100, I think 100 to 200 MB worth of updates which will get an update. If you have a fast connection, that should be pretty quick. um, so you do the upgrade first, but do the upgrade to bring in the terminal, you'll see on the top left corner, you'll see it's almost obscure here, but there is a little dollar sign with a greater than underscore sign here. That's terminal, and it's called Sakura. So the one default here is Sakura. It's almost has the same look and feel like you did in your lab. The only thing it doesn't have is tabs. You want another one, you just click another one, get another tab. If you want tab-based one, you can download using sudo apt install, either gnome terminal. I think, sorry, gnome terminal may not work here. Try libx11 terminal, or just search for on the web, you'll get it. Okay. So you type those two commands. You can see like here it says, oh, like when I did it for the first time, you're probably going to get the same or more at least, because this ISO image is, I think it's the same image we used, the 18.04. So you can see that it has all these packages to update, and it's 438 MB worth of packages, archives it has to bring from the web. And if you're ready, click yes, and it'll go on doing it. If you have a slow connection, just leave it on for a while, go do something. And during this upgrade, a lot of times it'll ask you, keep the local versions currently installed or not. Like here it is, some config file for the package manager apt and all that. Always choose keep the local version, almost always. And so that way it'll keep the local version and will not override it. So it just keep overriding the packages, but not change any of the configs and all that. There's nothing wrong with it, but it might mess up, and then you have to go back and change all the configs and all that. So that's why I chose to just keep it. Okay. And then in the last, if you're doing a lot of compilation and all that, so oh yeah, you definitely need JIT and Vim. Vim is actually not there by default. So you do sudo apt install is basically installing. Build essentially is it'll actually get all the tools, mostly C compilers, C libraries, linting tools and all that, which is need for building softwares. It'll get that. Nice to have that, although you will not need it for, because I've already built all the binaries for you, so you should not need it, but just keep it. And sometimes you need a C program, and you just want to compile a C program, write a small program, so you'll be all set. And then Vim and JIT, we need that before we start working on the lab. So that's it. Um, so this will get you started on the on your VirtualBox. So now you have a VirtualBox with Linux loaded on it. So and I'll highly suggest that you shut down every time you leave. You can actually put it in Hibernate, but sometimes if you have disk space, little disk space, it overrides it. You might have issues. So usually I just shut it down and start. But you can leave it, if you close your windows, that whole desktop will also be alive. So you don't need to always shut it down. You can leave it on. But if you're bringing down the desktop, I mean the Linux during the VirtualBox, you can also put it in Hibernate mode. So that way, next time when you start it, it'll just start in that same place you left it in. Like let's say you had Ngspice window open, one Sudo window open and all that, and you think, oh, I'm not going to come back to this for next 2 or 3 days, then just hibernate it, virtually hibernate it and leave, and next time when you start it, it'll start properly. Okay. All right, so this is the Linux part. So now what I'm going to do is, so you basically, now you have done the first part of it, setting up the Linux on VirtualBox. The second part is downloading all the tools and configuring it. And like I said, this is pretty straightforward because I've already compiled for you guys. So, and for each of these tools, like when you did the lab, all these tools were actually in the same repo. It was in one Git repo, you did Git pull and you had all the tools. Kind of spread it for a couple of reasons. One is, a lot of times people might want just Ngspice. So it makes no sense for them to get the entire 200 MB or whatever it is to get that. Plus, when I change the version or anything of Ngspice, I don't have to touch all these. Whereas in the previous case, I have to, you have to touch the whole thing. So that's why I decided to kind of split them tool wise. Okay. So now let me show you how to start the VirtualBox and start loading these tools. So you start VirtualBox, and once you have your Linux installed, you should see, like I said, I have CentOS 2 in this Linux one, and then you just hit start. Okay. And this is basically like booting your system right now. So it's going to boot. And I think I have I have 4 GB memory here now, 16 MB RAM. Like I said, 2 should be enough. I ran it 2. It just only recently um, I had to upgrade because I was trying to compile the Skyward PDK and I was running out of memory. So it's starting each of the Linux server services. Okay, I think successfully booted. Okay, so now you are here. You just have to type your password, which you gave during the installation, and enter that, and you should get the desktop. Yeah. Okay, so this is your desktop right now. Bring up a terminal, the Sakura terminal, like I said. Okay, so like I said, now I have the tools in separate repos. So what I would suggest is, instead of putting them all in your home directory, create another directory where you can put them. So for example, I'll make CAD as the directory, so that way it's obvious. So CAD, and let's start with Ngspice first. So what I did was, so for each of these tools, I have a separate Ngspice and Sudo and XSCHEM and all that GitHub page. So instead of repeating those commands here, I give you the link, so you can just go to the link here, and you can see there's a GitHub page for the Ngspice, and you'll see that on this it says current version. Okay, and just take a look into that. So when you check out, make sure you're checking out this version, because this instruction I may have forgotten to update. So just check this out. And the way I name this is, so this is the version for Ngspice. The .0 is any minor versioning I do for distributing. Like for example, I'm planning to include the Python libraries in Ngspice because I want to get away from the Sudo and CPP-SIM, but I want to get the Python libraries from there. So since the Python libraries are meant for Ngspice, so I'm going to put this in this repo, and I'll change this version to 34.1, let's say. And then what I'm going to send you is like, okay, everyone just switch to 34.1, and I'll show you how you're just going to type a git command. We're going to say git checkout 34.1, and that's it. Then you'll have everything else there up to date. You don't have to set up any environment variable, anything. And then you'll have the Python libraries. So tomorrow, let's say there is Ngspice 35 and it has some new modeling capabilities which we've been wanting or something like that. Then I would download, compile, and I would change this to 35.0. And then I'll ask you, okay, just switch to 35.0. Let's say you have some problem, then you go check out 34.0, and then you'll be back to the older version. So I'll probably keep like 3-4 versions. I won't keep like a lot of versions because they'll just take away a lot of disk space. So I'll just probably keep 3-4 versions here. So just make sure. So the first line, just see what the current version I have. So that way you know what to check out. Okay. So here, I have some quick start guide and all that, links to the Ngspice and all that. But obviously the first thing you need to do is um, download the compiled Ngspice, which I've already done for you. So here you can say, I said change directory to install directory, wherever it is. If you want to do it in your home directory, that's fine. But like I said, I'll do it in a directory called CAD. So I've already done that, CD CAD. So I'm already in home VLSI CAD. So obviously the user here, or even this whole thing, can be different depending on what you did during the installation, but it should be home, your username. And if you made a directory CAD, it should be home user CAD, whatever user username. To download, you basically type this command. So it's basically cloning the GitHub repo for the Ngspice, which is Silicon VLSI-org EDA Ngspice, just like you were doing in your lab. And here you can copy and do middle click, and you should be able to copy and paste. Okay, so let's do that. Should be pretty quick. Okay, so you have Ngspice here, and once you have done that, now what you need to do is you cd into that directory. So cd EDA Ngspice, cd EDA Ngspice, and here you check out this version 34.0. Now this is actually the main branch is 34.0. Even if you don't do this, it will still work, but just do this, because once I start putting more versions and all that, if you don't do this, then you'll be working on some, a recent version which is not working, or I have problems. So you want to face. So just check what this current distribution is. So 34.0, and you go here and you do git checkout v 34.0, and this is a name I have given. It's not like a JIT thing or anything like that. So when I created the version, I created v34.0. So it's a name I have created. So 34.0, I've made sure that it is prefixed by v, so just to make it obvious. And you check that out. Head is now, so yeah, it looks like it checked out. And the way to check out is you just type JIT branch. You do that, and you can see here it says head detached at v34.0. Anything related to JIT, you don't have to dig deeper into it, but essentially there are many branches of this distribution, and you are at v34.0 where you should be. Okay, so now you have the 34.0. So you can see all there are some documents, examples, and this is where all the binaries, where you have to set your path to access it and so on. So now you can go back to the CAD directory. And so let's see what's the next step is. So JIT checkout, and like I said, to check, just type this JIT branch, and you should see something like this, head at 34.0. And now you need to add those environment variables, just like you did in your lab, where you add this to your .bash RC. So I actually already have this because obviously I was testing them. So I'll just show you, and you can go ahead and add. So just make sure that you have the right, like for example, here I say install directory. What I mean is wherever you have installed it. Like for example, if you have installed it in home user CAD, like if you're, if your home, whatever your username is, VLSI or whatever your name you have put in, so it will be home that name CAD. So that's what you have put here. So home/user/CAD. Then this part should be exactly like this because that's part of this distribution. So this you should not change. Okay. So for example, I'll show you here. So for Ngspice, you can see it's home, $home. So you don't have to type /home username. So you just type $home. That's the environment variable for your home directory. /CAD /EDA Ngspice/GNLinux Spice lib directory. Oh, looks like I'm missing one. Share Ngspice. No, actually, I'm not missing one, but oh, okay, that's fine. This is fine. So what I did here is I created an environment variable first called Spice install directory, and then I use that environment variable here, so that way you don't have to type the entire path all the time. So this is fine. So these two are exactly the same. I just did it in a different way. So once you set the environment variable, then you're all good to go. So you can type ngspice now, and you can see, you should see ngspice version 34 here. If you don't see that, that means you're probably running your old version of ngspice or something like that. So make sure this matches the version you have downloaded. Okay, so you're done with ngspice. Now let's go to, what was the next one? Sutu. So this was part of what's that CPP SimLite. I changed the name to Sutu just so that Mike never comes back and complains that I'm using his tool name here. So I changed it just Sutu because that's what we are using. So there is a GitHub page here as well. So it has all the Python libraries here and so on. So same thing, just go to the download, and here also check the version. So you can see the version is 2.1 here. So it means like you're using Sutu, and I've probably added some examples and all that. So that's why it's on version 2.1 now. So you do the same thing again here. You go, actually, I can just copy and paste here. So copy. So this repo is called EDA-Sutu plus, and tab enter. Okay, so that's done now. So you go to EDA Sutu plus, and same thing. Now you check out the version. So here it is 2.1. Check out V 2.1. Again, looks like it did it. Just to double check, I do git branch, and you can see the head is detached at 2.1. So basically what it means is now when I am adding stuff onto the repository and all that, and let's say you did a git pull, you'll still be at 2.1. You'll not see it'll ask you that, oh, do you want to pull this and all that. You just ignore it, and you'll always remain at 2.1. Okay, so that's the advantage of keeping these revisions. So that's set. Now you set the environment variables for Sutu CPP sim, and again I have already set that as well. So you'll see for CPP sim I have the CPP sim home set, shared home set, the editor, and then the path. So once you are set with that, then now you can start Sutu as well. So you can see you get the same schematic editor you're using in the lab. And it's the same problem here. When you select anything over here, it has to be shift left key, otherwise it will not work. And that's a bug, probably a bug in the LXDE window manager here. So let's say you're using Ubuntu, you already have a Ubuntu desktop or a Debian desktop or something like that. You probably won't have this problem. Okay, so this is the problem with LXDE. All right, so we're set with Sutu. Let's see what's next. Next is, okay, like I said, XSCHEM is this new schematic. It's not a new schematic editor, but a lot of the open source communities are liking this now. So I just quickly tried it. I also really like it. It's lightweight, it's fast, it's very powerful. You can do pretty much everything you're doing at Sudo, but it has a lot more advantages. Sudo is not maintained anymore, and plus it has some quirkiness, like everything is in the install directory and all that, so I can't do root installation and all that. So this one doesn't have all that, and it's written in just plain C, so it's very fast and it's very light. So for people with kind of an older desktop or this thing, you'll see it, that it's still very, very fast. So let's get that. So same procedure again. We'll do git clone EDA XSCHEM. So okay, copy it, you can paste it. Okay, so that's done. CD XSCHEM. Sorry, CD EDA XSCHEM. And now again, you check out the current version number. Check out, and the distribution version is what, 2.9.90. So you have to append it with V, because that's how I give my tags for all this versioning. So this should be on the right one. If you type the wrong one, it'll give you an error, and when you do the just git branch, you'll see that it is still on main. Main is like the recent one where everything is just current. So you should see that. If you had any problem checking out, you'll see it. So typically that means you just typed the version number or naming wrong. Okay, so just try to fix that and it should work. So we're done with the schematic, and then again you set all the environment variables. And here it's actually pretty straightforward. It just, you have to set the binary path. And again, I've already set this in my bash RC. So if you go down, you see here, there's just one path set here. So that's set here. So if I type XSCHEM now, obviously I had the sourced bash RC. So for you guys, when you're writing it in the .bash RC, you have to either start a new terminal or source that file. Otherwise, you type XSCHEM and also command not found, just don't go screaming like, oh, the command was not found. That's because for me, those environment variables were already there. So when I started my terminal, so they're already, all those paths are there, and I am actually downloading all of them in that path which was already there. Okay, so for you guys, when you add it, you have to either source .bash RC or just kill the terminal and start a new one, right? And if you type XSCHEM, so this is the new editor, like I just said. I mean, go through the documentations, you'll see that I haven't played around with it much. And the nice thing is I can actually attach the Ngspice to this. So you can do the simulation, and how you're doing the netlist where you're writing the control statement and all that. You can actually put those control statements here and hit simulate, and it'll simulate. For the first timers, I don't like that. I still like people going through it through the netlist and doing it, which I think you guys have gone through. Now you can use this and simulate straight from the schematic editor itself. So for me also, it is very new. I haven't tried it yet, so I'll slowly start looking at it. But I would suggest you guys use it, and some of you can take a manual. I'll be happy to put it here, or you just do a fork of this git fork and put all the documentations here. That'll be a really good exercise for you to see how to contribute to open source projects, right? So this is a way to contribute to open source projects. Okay, so we've done XSCHEM. So now let's do magic. Same thing, git clone the magic repo. And the magic version is 8.3.178. So I'll just copy that. So git checkout version 8.3.178. Oh, sorry, I have to go to EDA Magic first. do git checkout. So hopefully, yep. So this is done. Next is Netgen. And yeah, again, all the environment variables are set. So you go ahead and set that and you start. So Magic should start for you as well. The next is Netgen. So go to the Netgen web page. I mean the GitHub page. Clone it. Okay, cd Netgen. Then git checkout v, and the current version is 1.5.185. 1.5.185. Looks like that's done. Yep. Then go back, and then the last one is not a tool, but this is where, so I made a separate repo for all the technology files. So you know your model files, your magic technology files, those will be all here. So right now I have SC4M, which is the one you use, the 0.5 micron. This is the older technology. I'm trying to get the Skywater 138 nanometer. But I've still been not successful compiling the analog PDK for this one. So, and this one is, you don't have to, I haven't done any versioning or this, so you just check out and you don't have to set any environment variables or anything like that. Okay. So now all your model files and technology files, they are in this EDA technology. So for example, if you go to the SCN4M, you'll see there should be a models directory. You go to models directory. You can see this is the same lib file you use for your lab, right? You can see this is the different nominal, fast, and slow corner, SCMOS and SCMOS-P. So this is where you have to give your path now. So whatever path you had for your lab, that's, sorry, not path, PWD. So this is the path you have to give. So home, so $home, CAD, EDA technology, SCN sub 4M models, and then this path, BSIM 3V41. Okay, and one other thing I wanted to show you, and the magic files are also here, right? So if you go to the maglib, um, mag SCN4M, yeah, CD maglib. So you have all the, actually you have a lot of those. So we copied some from the Open RAM. There is a project called Open RAM going on. So there is a lot of 60 RAM cells laid out here. So you can actually compare and see how good you are comparing to this. So where's the technology file? Tech. I think it's the tech.py. No. So Sandan, which is the technology file? Is it, oh, SCN4M, right? This one here. Yeah. Yeah, so now you have the technology file, so you can actually load layouts from that library. So you can see S60 cell here. So this is actually a memory cell. So this is what you're going to lay out. It's a very compact 6-transistor memory cell, which can be repeated. So this stores 1 bit of memory. So you have a megabyte of memory. You'll have 8 million of these cascaded right next to each other, right? Obviously, this is big because it's older technology. In present technology, this is like, almost a micron by micron. Okay. So the technology directory has all that. So always refer to the technology directory. If you want to use something because you're changing, copy it to your local directory, but you should always refer everything to the technology directory. That way, if there is any changes needed to be done and all that, I can change it and you see the reflection right away. Otherwise, you'll be trying to figure out, oh, which change did I do, this and that, all that. So that's it. So this should take care of loading all the tools, the technology files, and you'll be able to use um, all the tools right now, open source tool which we used in the lab. And then we'll start adding more digital tools and whatever is needed in the future. Like technology, as we keep adding it, it'll get updated. You just have to git pull or git check out the new versions.